module 1. It's your introductory portion. So today we'll start with our next module, means module 2, that is based on that different working principle and the concept of the switching converters. Means you know that different types of solid state devices we have normally used. Okay, so here we have discussed about that different topologies of solid state devices. Okay, and means you can understand. So what are the different types of solid state devices? Means like you know about that unidirectional switches. Okay, because I have already discussed that solid state devices are used as a switches. That's why it is given, the title is given like that, switching converters. Okay, so you know that the basic differences of that linear converters and the switching converters. So now we are much more focused about that switching converters. So here in this chapter, in this module, actually we are going to be discussed about different types of switching converters, like your BJT, diode. Okay, diode, BJT, and what are the different then MOSFET, IGBT. These four are the most important thing. I think ACID is also be there, but we have also discussed about some idea about the ACID. But our main target will be that operations of different switches. Okay, that means how it is working in the unidirectional way. If it is in bidirectional, so what will be the structures. Okay, so combinations of different switches. Okay, structures of combinations of different switches and their working principles. Okay, so so here you can understand that what are the basic, you can see what are the basic realizations. Okay, so why we are going for the different types of switching converters. Okay, so the basic realization is, first one is the switching applications. Okay, because we are doing everything based on that application purpose. Okay, so basically I am following the basic idea about that fundamental of power electronics by Ericsson Maximovic. Okay, so that books I am normally following. Okay, so the it's a we can use as a reference also. Okay, because we have not till now we have not given any reference. Okay, so that's why I'm telling by own mouth. So we are normally following this book. Okay, so after that we can also follow different books, because this portion I'm taking that Ericsson book and different materials available by that Ericsson. Okay, so you can observe that switching realizations. Okay, so basically we are going for that application. So everything is application oriented. Okay, our first agenda is that application. Okay, so where it is going to be used. Okay, so based on the applications we have selecting the switching, selecting the switches. Okay, so first one is that switch application. Is it single, two or four quadrant switches? Okay, means what kinds of operation will be there. You know that if you use some of the switches. Okay, in case of machine drives. Okay, so you know that in case of machine drives, that both four quadrant operations also be possible. Means four quadrant means you can understand that voltage and current. So that means that you can see that second quadrant operations. Okay, so one of them will be negative. So negative, if both of the operation if applicable in a single switch, then how it will be possible? Definitely the current flow of that switch will be different in the second mode. Okay, so that provision must be there in the switches. So in machine drive, so different type of braking. Okay, forward braking, reverse braking, means you can say like the motoring, then regenerative braking. Okay, reverse motoring and reverse regenerative. So four quadrants operations are normally you can observe over there. Okay, that's why the selections of the switch also depends upon your applications. Okay, so where you are using those switches. Okay, so as well as that rating of the switches, because I have already discussed everything in these chapters and entered the power electronics chapter. Most of them are the power electronics converters. So basically, what is the difference of analog electronics converter and the power electronics converter? I think this portion already been discussed in your power electronics classes. Okay, because it's also power electronics class, means super speciality of that some of the portion of the power specialty. Mainly thrust area in this subject is that modeling of the different switching converter. Okay, control designing and their applications. Okay, that means different mode of operations, means voltage mode operation, current mode operation, means everything. The basically the design of the subject, basically the practical applications of that switching converter. But the conventional studies also be there, some of the portion, because you know that direct modeling is not discussed in the power electronics subject. Okay, so that subject most of the cases dealing with that different switches, structure, graph, okay, operations. Okay, then you can go for different topologies, means you can go for that basically the basic operations of the diode, how it will go work by the power MOSFET. Everything will be discussed over there. But in this chapter, we are normally focused about related to the switching converters. Okay, that related portion of the switch mode power converters. Okay, so that's why we are much more focused about the related ideas about it. So I think you all of you understand that the mode of operations, sorry, that the quadrant of the operations also decide your type of the switches. Okay. Then the brief survey of the power semiconductor device. So because basically this switches chapter also be there. Means we are discussed about very brief idea. We are giving it the very brief idea, not the in-depth idea will be discussed over here. Because I have told you the basic structure mainly focused about that designing of that switching converters. Okay, so that is most important, that is the important thrust area of this chapter. So we are discussing about that basic power switches, means power diodes, MOSFET, VGT, IGBT and thyristor, but basically we are not going into depth study about it. Okay. Then important idea is your switching loss. Okay, so switching loss means that your so please mute all of your microphone. Okay, why you have forgotten? Let's make some noise, no? Okay, so now next idea is that the switching losses. So why that switching realization is most important? Okay, switching losses means you can understand that thyristor switches, switching with the clamped inductive load, diode recover, recharge, state capacitance and inductance, and that ringing. Okay, efficiency by switching frequency. So one by one we can go for that. So how much recovery reverse recovery time is there in case of power diodes. Okay, so if there is stay capacitance and inductance in the, because you know that energy storing, you have to dealing with that energy storing element. So how much amount of energy is stored over there and how it will be applicable. Okay, everything will be there. Okay, so basically it depends upon your applications and that stay magnetic stay energy storing elements. Then ringing effect means you can see that some of the oscillations, means when ring are there, then you can observe that some of the oscillations is there initially of any of the responses. Okay, so it will be that is called ringing. Okay, so oscillations means starting you have got a square wave, but the starting of the square wave is coming oscillating. Okay, that is normally coming due to the ringing. Okay, then efficiency by the versus the switching frequency graph. Okay, so definitely it will be all the portion will be discussed in this chapter. Okay, in this module here you can see that SPST switches means single pole single throw. So okay, so what is single pole single throw means you can understand that it's a at a time it will be showing at a single side, so maybe one, maybe two. Okay, so that is your, sorry, I have missed it is single pole double throw switch. Okay, means one pole is fixed. Okay, but it can go for the two types. Okay, another one is SPST switch, that is your single pole single throw. Okay, so here voltage and current polarity is defined. Okay, so here you can see that here you can observe that when switch only one terminal is there. Okay, so when that switch is connected over there, only that current will flow over there. But when it will be not connected, so only voltage will be there. So you can say like that, single pole single. So switch which having the voltage and current polarities defined. Okay, so I think you are able to understand that what is the purpose of it. And in case of all power semiconductor devices, as a function of a SPST, means single pole single throw. Okay, so that's the basic idea about that single pole single throw switches. Okay, so I think you are able to understand that I think you are able to understand that how it will be work. Okay, so I think my slide also visible from your side. On comment
Yes.
is
Yes, sir.
Yes, sir.
yes. No? Okay, okay, okay. Okay. Hmm. So here you can see that it is single pole single throw. Then you can see the single pole double throw switch. Okay, so where two of the terminal will be there. So at a moment it will connected with the maybe one, maybe two. Okay, so you can say like that it is two where you have used the two single pole single throw switches. Okay, means it may like that. You can see if you compare both of them, so you can understand the differences of single pole single throw and single pole double throw. Okay, in case of single pole double throw, so one gate pulse will be there. So what happen? One control signal is required. Okay, so one control signal will required, that will decide. Okay, both the cases it is required, that will decide when it will be one and when it will be two. Okay, in case of two, if you compare both of them, so you can understand here only single pole single throw switch is there. Okay, so only one terminal at A and B. Okay, two switches are there. At a moment only A will be connected over here, at a moment it will be connected over there. Okay, but what will be the main problem? Problem is that here you have to use two additional switches. So instead of two switches, you can use that common configuration. Okay, so here you can see that portion will be change. Okay, first it will be connected over there, second it will be connected over there. So you can replace that one with a SPDT. So when this point will be directly connected over here, and the point will be connected over here as per your requirement. Okay, then you can see that in rest of the thing will be same. You are taking the structure of a buck converter. Okay, LC is there, just taking the buck converter, LC is there, then you are comparing all of it. Okay, so your load also be there. So what will be that output changes? Definitely output will be same, but the complexity will be different. Okay, the realization of that in SPDT switches using two SPST switches. Okay, so what are the realization? Instead of using SPST switches, the first one is that non-trivial steps, means two SPST switch are not exactly equivalent to one SPST switch. Okay, it is not exactly same, but means it is not exactly equivalent. Okay, but it is possible for both SPST switches to be simultaneously on and off. The behavior of the converter is then significantly modified, so discontinuous conduction mode may be there. Okay, the conducting stage of SPST switch may depends on applied voltage of the current, for example diode. Okay, I think all of you are able to understand. So if here you can see that it's also sometimes directly you are connecting from 1 to 2. Okay, means one will be disconnected and two will be connected. Okay, maybe load is different. Here you can see it's a resistive load. If that load is inductive, then what happens? So you have to wait for some moment. So up to when that energy, total energy will be dissipated, then you can go one terminal to second terminal. Okay, so that's why it is written that it is not trivial steps. Two SPC switches are not exactly equivalent to one SPC switch. Okay, so it is possible for both SPC switch to be the same simultaneously on or off. Okay, so when it will be on, so you can see that when switch A will be on, switch B will be off. Okay, again that when B will be on, it will be off. Okay, So it may be observed for where it may be observed. You can see it's a diode. Okay, diode application. You can see like that conducting state of SPST switch maybe depends on the applied voltage or that current. Okay, so depends by whom it will be decided, means maybe voltage, maybe current. Okay, behavior of the converter then significantly modified. So because sometimes what happens, if you want to go for discontinuous mode of operations, then what happens, then for a single switch it is quite difficult. That's why if you want to go for discontinuous mode means that IL current, that current will be zero. Okay, so when if you want to current to be zero, then it's sometimes may be problematic. Okay, so in that case SPST switch is much more suitable compared to your SPDT switch. Okay, so it's have some realizations. Okay, then you can see that quadrants of the SPST switches, that's why we are much more focused about the SPST switch. So simple thing, from the figure you can understand 1 and 0. Okay, so two terminals are there, 1 to 0, current is flowing over there. So current is flowing 1 to 0, so potential drop will be across plus minus, it is V. Okay, so both current and voltage is positive. So what is written like that, switch on state of that current. So current is required at the on state. Okay, so switch off state of voltage. Okay, so maximum when switch is on. Okay, switch on current, when switch is on, that current will be what, when switch will be on, so current will be maximum. Okay, but voltage will be minimum, so voltage will be 0 here and current will be maximum. Then what happens, gradually, so when switch is off, when switch is off, so you will get that maximum voltage but current is minimum. Okay, so that's why you can understand that it's the first quadrant operation. When on state means I greater than 0. Okay, I greater than 0, and off state means V greater than 0. A single quadrant switch example. Okay, I think you are all of you able to understand. Okay, the realization, the current and voltage is positive, that's why it is first quadrant operation. Okay, then in case of second quadrant operation, what happened? So some basic switches application. So for first one is that single quadrant switch. Okay, that is your single quadrant. So switch on state of current. Okay, switch off state current. Okay, so first quadrant operation, that is single quadrant switch. Okay, the realization of switch is single quadrant. You can see one. Okay, then what happened, that current and voltage both may be positive. Okay, both should be greater than 0. But current bidirectional two quadrant switch, what happened? Current bidirectional, because in second quadrant switch what happened? Current will be, you can say like that, voltage is in your x axis, current is in your y axis. Okay, so current is in your y axis. So bidirectional current means current should be positive y axis sometimes, and sometimes it will be coming negative y axis. So bidirectional current, that's why it is written bidirectional current. By current bidirectional two quadrant switch. Okay, so that's why you can say like that, switch on state current, switch off state current. Okay, so I am giving the very basic brief about that idea. Okay, bidirectional switches. Okay, that's the concept, basic concept. So for the better understanding, and I have also much more focused about elaborate study. Okay, because it's your most important subjects, power electronics, switching converters. Okay, so better you have to go through. I have given the very basic idea and the very basic understanding on the realization of this subject. So for the in-depth study, you have to follow the books. Normally, I have prepared that material based on that Ericsson book, that is Fundamental of Power Electronics. Okay, so you can follow that book. That book also very good. Okay, so you can follow any other book that I have already mentioned in my first slide. Okay, which books you need to be followed. Okay, so for the better realization, better understanding, better, because if you did that in this study, so your concept may be developed well. Okay, so then you can see here, you can see that on voltage is positive, current is negative. Sorry, current sometimes positive, sometimes negative. So same thing also happened here, that is voltage bidirectional. Okay, both of the voltage may be there. Voltage is positive as well as negative. and two quadrant switch. Definitely it also two quadrant switch, it is two quadrant switch, it is single quadrant switch. Here you can see current always positive, okay, current always positive, but voltage sometimes you can see of voltage sometimes it is positive x-axis, sometimes negative x-axis. So sometimes voltage is positive, sometimes voltage is negative. So these all are the happen for that applications. Okay, some of the application is like that. Okay, so based on your application, so you have to find out the characteristics. Okay, you know the characteristics of the solid state device. So based on the application, you have to select the solid state device. Okay, so for which solid state device this type of idea is coming. Okay, so you have to design the solid state device, means you have to, and you have to design sometimes and you have to implement. Okay, the solid state device. I am coming. Okay, so in my next slide, so you can understand. So four quadrant switches means both of the current directions and voltage. Okay, appear across your switches. Both should be reversed, and okay, so both may be positive, both may be negative. Okay, means positive. So voltage may be positive x-axis as well as negative x-axis, and current sometimes may be positive y-axis, may be negative y-axis. So both of the operations may be there. Okay, that's the way for four quadrant switches. So here you can see that single quadrant switches. So what are the basic switches are there for the single quadrant switches? So here you can observe the realization of the single quadrant switches. So it is plus minus is there. Okay, voltage is also there. So current is flowing from 1 to 0. So I current is there. Okay, so it is your active switch. Okay, what are the different types of switch? Passive switch. Okay, then silicon control rectifier switch and single quadrant switch. So okay, so what are the most important portions? So what do you mean by the active switch? The switch state is controlled exclusively by the third terminal, maybe control terminal. Okay, definitely that I am telling you, that get terminal. Okay, the switch stage is controlled for the active switch. Okay, like your active element means you know that in case of active element the additional EMF source will be there. Okay, so it's there already. The circuit having capability to develop some of the EMF sources. Okay, means some of the EMF booster some of the EMF booster properties is there with some of the elements, that is called that active element. But active switch you can say like that, some third terminal is required for the control terminal. That terminal is known as control terminal. Okay, so in case of MOSFET you can say like that it is gate. Okay, in case of IGBT it's also called like a gate. Okay, so like that. Okay, in passive switch the switch state is controlled. You can say like that, the switch state is controlled by the applied current or the voltage terminal 1 and 2. So applied current, okay, that is the current is there. So passive switch stage is controlled by the applied current and voltage, sometimes ending current and voltage or current or voltage at the terminal 1 and 2. So from the terminal 1 and 2 sometimes current and sometimes voltage. Okay, both are take responsibility for controlling that switch. Okay, that is called the passive switch. In that case no additional control terminal is there. Okay, so without any control terminal the controlling of the switch may be observed. Okay, so in ACR the special cases are there. Okay, so turn on transition is active. Okay, while turn off transition is passive. Why? Because in turn on terminal you can say like that there is some contribution of the gate pulse. You know the definitions of the latching current, you know the definitions of the holding current. Okay, you know the effect of the gate pulse. Without having any gate signal, if you want to go for that turning on that devices. Okay, so that another that's the basic, so maximum. So then if you giving the some of the gate pulse, then you can see that applied it will be turned on quickly. Okay, so gradually it will be decreased, that gate pulses will be decreased from maximum. So if you increase the gate current, so that voltage, so initial voltage will be taking less. Okay, that's the concept. So that you can say like that, for the turn on transition is your active. Then what happens? Then ACR is your latching device. Latching device means it's like your door. Okay, so in your home you can say like that it's your door. So if door is open, Okay, if door is open, so if you don't have any controlling unit over there, means it's an, if you connect one auto recloser with your door, so then it can only be closed by automatically. In case of SCR, it's a latching device. Okay, so there is no controlling part. That means after turning on, there is be no effect of that gate pulse, means there is no control of the gate pulse to the circuit, to the device. Okay, that's why what happen, you have to increase, so you have to, in which cases, so you have to depend additional circuit for that turning off that SCR. Okay, means you have to design some of the commutation circuit. Okay, so commutation circuit means what happens, so current is flowing. Okay, so current is flowing through that SCR, through the SCR. So you have to make that current is zero. Okay, for making it off. So how it will be possible? So you have to provide some counter current over there. So that's the arrangement is there. So different types of arrangement is there. That is called the commutation circuit. Okay. So that's why in that case there is no control of the gate pulse. So that's why it is written like that. The turning of transition is the passive. Okay, I think all of you are able to understand. The single coordinate switch. Okay, in case of single coordinate switch, two state are there, on state and the off state, and their working will be unipolar. Okay, you can say like that, only unipolar, plus minus. It's not the bipolar. Bipolar means sometimes it will be plus, sometimes it will be minus. So it's a unipolar. Okay, so on state is your I. Okay, on state means you are getting some of the current is flowing over there, it is I. Off state means some of the voltage always be there, so it is V. So it is the basic behavior of single coordinate switches. Okay, so you know that what is the realization as per your structure of that control. So you can see what may be the tentative devices, solid devices. So it's a diode. Okay, it's a diode. Okay, so in case of diode, what happened? You can say like that. The structure of the diode, it's a power diode. So it's a total black color. Okay, it's a black color means it's a power diode. Okay, in normally mood diode you can say like that, mood MUR 450, maybe this different names are there, means as per that fabricating as per the manufacturing companies, the different names are there. So in our cases we are more cases more application we are using mood diode MUR 460 most of the cases. Okay, MUR 460 means what is the rating? So 460. Okay, 4 means it may be 60 means maybe, I think we have to check the data sheet. Maybe the 400 volt it may be taken by this diode, and 4 means it may be that 4 ampere current rating. Okay, so 60 stands for maybe voltage level, that is 400 600 volt. More 460, no? So 600 volt, and 4 is there ampere, I think so. MUR 150 also be there. Okay, so that means 1 means 1 ampere. Okay, and 50 means MUR 150. So last two digits, 50 means 500 volt, and 1 means it is 1 ampere. Okay, so that is your mood diode. In case of signal diode, you can say like that IN4007. Okay, so IN400, sorry, IN 1N4007. 7. So that 7 means it will work maximum 7 voltage. Another thing is also be there, another type of, so 1N4001. 1 means maximum it will the working range of this diode, means analog diode, maximum is up to 1 volt. Like that, you have to check the data sheet. I am telling some of the idea about it. So you can say like that. It is a symbol, and what is your instantaneous IV characteristics of the diode? So you know that it is positive V. Okay, so V is there and I is there. So IV characteristics. Okay, for on state you are getting what for one on state. So here, so you will get for ideal cases. So maximum current you will get when voltage will be 0. Okay, so off state, what will be the value? So maximum for the off state, when it will be off, when diode will be off, means reverse voltage will be applied, only that diode in that case means diode will be off, means for the, here you can see anode, the anode and cathode. Okay, so positive and negative. Okay, so both are in forward bias. Okay, so both are in forward bias, and so it will be passing, the some of the current is passing through the diode. Okay, so you will get some for ideal cases what happened, there is, you can consider there is no internal voltage drop will be there, okay. But when off state means you have to apply reverse bias, that means you have to making the diode reverse voltage. So that voltage will be different, okay, means like that. Here it is written now how it will be controlled. The applied current or and or voltage terminal, current applied and or all voltage at terminal 1 to 2 means that voltage terminal will be different, okay. So in that case it will be off, so reverse voltage will be there. So that's why in off state you can say like that negative direction, that voltage is there. If it is positive x-axis, then negative x-axis, so it is coming minus plus, so minus V will be there, okay. So in case of diode, okay, so what are the most important features? A passive switch, it's a passive switch, single quadrant switch, it's, you can say like that, it's a single quadrant switch, okay. 1 minute. So it's a single quadrant switch, okay. So can conduct on positive on state current, okay. So that means it can only possible conduct current in that forward direction, can block the negative offset voltage, you can say like that. So negative offset voltage, you can I think you are able to understand the plus minus is there, okay. So it is it will be deferred, okay, positive plus minus, so can block the negative offset voltage, okay, it can block over there. The provided that the intended on state and off state operating points lie on the diode IV characteristics, then switch can be realizing using the diode, okay. So I think all of you are able to understand that these all are the basic features, okay, very common and basic features of the diode. So definitely conduct only positive on state current, then blocking the negative state. Normally we know that reverse recovery breakdown also be there, okay, but I am not considering such a thing. So huge voltage will be there, so after that huge voltage will be there, then it will be operated, okay. So provided that intended on state and off state operating point lie on the diode IV characteristics, then switch can be realized using a diode, okay. I think all of you are able to understand. Then we can go for that, what, that bipolar junction transistor, that is your BJT, okay, bipolar junction transistor, and insulated gate bipolar transistor, insulated gate bipolar transistor, it's your IGBT, okay. So it's your BJT, another one it's your IGBT, okay. So in case of BJT, you can understand that collector, okay, what are the most important terminals are there. So all the cases you can say like that, C means it's your controlling unit, okay. So it's your controlling unit, okay. So normally we are using that active switch controlling terminal. So controlling terminal they have mentioned by the C. C is not stands for the collector, okay. Normally you know that common emitter configuration, that is your B, that is your B means base terminal, okay. So that is your B, and it's your C. C means collector, it's your collector, and 0 means it's your emitter, okay, normal cases. And IGBT, it will be gate, okay, that is your gate, again it will be C and D. So gate, emitter, and gate and emitter, but here you can see like that C means controlling terminal, okay. So it's an active switch. Why it is active switch? What are the features of the active switch? You know that active switch, the switch state is controlled exclusively by a third terminal, that means control terminal. You can know that a control terminal is there, so that's why it's a active switch, okay. I think all of you are able to understand the meaning of that active switch. So it's an active switch, okay. Single quadrant switch, okay. When control signal will be positive, sometimes negative. When it will be positive, you will get some of the, it will be on, okay. On means again current will be there, and when it will be off, because you are controlling, you are not changing the terminal voltage, only you are giving the signal to the controlling terminal, and that is that is control your solid state device. So when the positive bias, positive state will be there and negative state will be there. Okay. So sorry, it's a square wave. Okay, so positive, then it will be 0, again positive, like that. Okay, so as per the signal, so it will be on and off. So I is there. Okay, here your I and V. So that control pulse will be there, means you will get some of the potential across that path. Okay, so means on state means I will be maximum, but V will be 0, and off state when that control signal will be 0, so switch will be off, so total V will be appeared over there. So it is positive x-axis only. It is single quadrant switch. You can think, I think you are, it's a single quadrant switch, can conduct okay, positive on state current. Definitely it can conduct positive on state current, can block the positive off state voltage. Here it can be blocked over the positive off state voltage, provided the intended on state and off state operating point lie on the transistor IV characteristics. Okay, so then the switch can be realized using BJT or IGBT. So it is a, when the applications is your positive half cycle, means positive quadrant. Okay, there is no direction changing of that current, so directly you can use that one. Okay, so you can see that structure is like your single quadrant switch structure. Okay, so here it is single quadrant, both of the cases single quadrant switch. Here the voltage is, blocking voltage is negative, but here it is positive. Okay, so as per the application, when switch off condition, negative voltage is required, you are using the diode, where otherwise you are using that BJT and that IGBT. Okay. In case of MOSFET, okay, so in case of MOSFET, so it is written that the metal oxide semiconductor field effective transistor, or the MOSFET. So what happened in case of MOSFET? Again, it's an active switch, because you know that is control switch. So C is your gate. Okay, gate drain source. Okay, gate drain source, and controlled by the controlling terminal, it's you see, normally operated as single quadrant switch. Okay, single quadrant switch can conduct positive on state current. Okay, can also conduct negative current in some circumstances. Okay, so it can conduct positive on state current and sometimes work as a negative off state current. Okay, so I think all of you able to understand negative as well as positive. So MOSFET, you can understand one thing, that MOSFET can conduct on positive on state current, can also conduct negative current in some circumstances. So it's also possible for conducting negative current. So on side, off side, positive y-axis, negative y-axis, both of the sides is there, and reverse conditions. Okay, so condition is there, reverse condition. Can block positive offset voltage. Okay, it can block positive offset voltage. Definitely when it will be turned off, so positive voltage will be there. Okay, so it's your symbol and it's your instantaneous IV characteristics, can block positive offset voltage. Okay, provided that the intended on state, okay, what is written, that on state and off state operating points, okay, on state and off state operating points lies on the MOSFET IV characteristics. Okay, so application wise, okay, then the MOSFET can realize using that MOSFET. So only thing, you know the characteristics from this diagram, and if your characteristics is matched with your application, okay, so as per your application you can choose your solid state devices as a switching converter. Okay, so till now I think all of you are able to understand the basic realization. Okay, after that then we can go for the realization of the switching using the transistor and the diode. Okay, so previous one you can see that is SPST switch operating condition. So switch A means that one, switch A. So it's a transistor. So transistor is working which direction? You can say like that. Transistor is working positive. You can say quadrant 1. I is positive, B is negative. So here your I is positive. You can say like that, A switch. Okay, it's an, you can say like that, all the condition current is coming like that. I is positive, B is also positive. Okay, so you can say like that, switch on. So IA is there and IL when switch is on. So IL and IA both should be in the same direction. When switch is off, okay, when switch is off means switch is off, then what will be the voltage appear across over there? So VA voltage will be appear across over there, that is your VG. VA means VG. Okay, so that will be across over there. So both of the terminal point will be there in the positive y axis as well as positive x axis. When switch B is there, okay, so for which this characteristic, so it should be maintained, okay, all the time it should be maintained. So which switch is following these characteristics, you can say like that, that BJT or IGBT is following this characteristic. So I, V and on and off, so it is first quadrant, okay, so it is matching with that one. So BJT or the transistor, so you can say like that, switch A is characteristics, required characteristics is matching with your transistor, okay. So in case of second case, okay, second case for switch B, okay, switch B, when switch B is on, okay, so when switch B is on, so you will get that if it is your VB but negative VB is there, okay, so you can say like that minus VG is there, so it's your minus VG, switch is off, B is off, and current is same, current is IL current, always similar to your IB, okay, when switch is on, so it is coming which direction, positive I but negative V, so it has matched with the diode, okay, so switch B will be diode, okay, so switch B will be a diode, so it can replace by a transistor, it can replace by a diode. So that's the realization. In case of buck converter, you can understand that you are using one switches over there, okay, so that may be transistor, okay, or IGBT, and here we are using that is your diode, okay. That's the basic concept, simple concept. I think all of you are able to understand SPST switch. So here you can see the final realization of your circuit, okay, final realization of the circuit. So instead of the realization of the buck converter, okay, it is a buck converter using single quadrant switch, so that is a single quadrant switch, okay. So diode is there in switch B and it is a transistor, okay. So VA and VB both will be there, positive negative, positive negative, IB is there, okay. So switch on, switch A on, that is your IA, then switch A is off, that is your VA, so VA VG, okay. So all the thing will be there, okay. So you can realize the entire thing, so simple portion, okay, but as per the realization you have to select the solid state devices, and that solid state devices must be working as a switching converter, okay, it must be work as a switch, okay. Then we can go for the next thing, it is coming the current division. I think that is enough for today. So next class we'll discuss about the current bidirectional one, okay. So still some time is there, okay, but that portion will be, I think I will discuss about that portion in next class, okay. So till now if you have any doubt you can ask me, so if you want any kinds of clarifications, repeat discussion, so I can definitely I can able to give some answers. So if you have any doubt over there. Okay, if you have any doubt you can ask me.